Third case. Okay, strategy C, no odd powers, or we can say even power of both sine and cosine, that is. Okay, so we're looking at even power of both. In this case, we need to use double angle identities. There is one identity, but we have two variation. Okay, I want to remind you something like this. What is the cosine of 2 theta from trig? Okay, cosine of 2 theta has three variation of the identity. The one variation is cosine squared minus sine squared. The other variation is if you substitute the sine squared with 1 minus cosine squared, then you have cosine squared minus 1 plus cosine squared, or you have 2 cosine squared minus 1. On the other hand, if you substitute cosine squared with 1 minus sine squared, you have 1 minus sine squared minus sine squared, or you have 1 minus 2 sine squared theta. And you all learned it in trigonometry. I'm just going to refresh your memory. Okay? Now, if I'm going to solve for cosine squared or sine squared, okay, then you have, if I'm solving for, let's say, cosine squared, okay, if you think about what you're going to do, you're going to add 1, so now you have 1 plus cosine 2 theta, and you divide by 2. So it will be 1/2 times 1 plus cosine 2 theta. And if you solve for sine squared, oops, I didn't write it in a good form, so let me write it out. I'm going to write below, and then I'll let it dry and come back to it. But if you solve for sine squared, look, you have 2 sine squared equal 1 minus cosine 2 theta, so sine squared by itself will be 1/2 1 minus cosine 2 theta, like so. Okay, so that will be one useful identity, and the other useful identity will be on top for the cosine squared. Let's see if it's dry enough. Cosine squared of theta will be 1/2. Again, you're solving, so you have 2 cosine squared equal 1 plus cosine 2 theta, and you divide by 2, so it will be 1 plus cosine 2 theta. This is really, if you think about it, in trigonometry, we use that for half angle identity. This is, if you substitute 2 theta with x and theta with x over 2, and you take the square root, this is exactly the half angle identity from trig. Okay, so even I call it the double angle identity. I call it because that's where we started with. And we end up having double angle, but it is half angle. So let's see how this plays out, in how we're going to solve that. I have 2 examples that demonstrate this strategy. Okay, so let me keep this on top so people can still catch up with me. The first example is a straightforward, we call it example 3 for This is the third strategy. And in this case, we're going to evaluate, just for the heck of it, instead of dealing with the indefinite integral, we're going to evaluate a definite integral, the integral from 0 to pi of sine squared theta d theta. Okay? So the integral, I, we go from 0 to pi of sine squared theta d theta, and I'm looking here and I see the substitution, so it will be simply the integral from 0 to pi of 1/2 1 minus cosine 2 theta d theta. Okay, so we can I can factor out the 1/2, so I have the integral of 1 d theta minus the integral from 0 to pi of cosine 2 theta, like so. Okay, so the integral of d theta is theta, so we have 1/2 theta. What about the integral of cosine 2 theta? Well, if you take the derivative of sine 2 theta, you have 2 cosine 2 theta. So we need to have half of it, so it would be 1/2 of sine 2 theta. Okay, and you can double check. Okay, you take the derivative here, you have 1/2 times 2 cosine 2 theta, or simply back cosine 2 theta. Now you evaluate it, you look at the sine. Sine of 2 theta, 2 pi is 0, and sine of 0 is 0. So the second term is 0, and here we have 1/2 pi minus 0, so the result would be simply pi divided by 2. Are we good here? This was simple